Good day, you postulant Pythagoreans. Today we will work on the gray problems in 12.4. But first, we will look at this piece of art, which is called Pythagoreans Celebrate the Sunrise by Russian artist Fyodor Branikov from 1863. Alright, let's begin with problem 12.19. Open to the right page and read along with us. Page 322. A quadrilateral is said to be a cyclic quadrilateral if a circle can be drawn that passes through all four of its vertices. Prove that if ABCD is a cyclic quadrilateral, then angle A plus angle C equals 180 degrees. Now I want to point out, first and foremost, that the thing we are trying to prove is not that if angle A plus angle C is 180, then it's a cyclic quadrilateral, because that's not true. Imagine a rectangle, a very long rectangle. That very long rectangle is not necessarily a cyclic quadrilateral. You may not be able to fit a circle to pass through all four of its vertices. However, if we have a shape that is a cyclic quadrilateral already, then we should be able to prove that angle A plus angle C equals 180 degrees. Alright, so we want to just think through this for a moment. You see the word prove, and you might feel a little uneasy. You don't know what to do. But the first thing I do is I draw a circle, a bunch of circles, and I make a bunch of cyclic quadrilaterals. So we have a four-sided figure whose vertices are all on the circle. And there you see it. And then I have the last one labeled. That's the one we'll ultimately work with. And so the claim of this problem is that angle A plus angle C is 180. Not that both are not 90, obviously, but that if you combine them, they are 180 degrees. The same would be true of angles B and D. Let's look at our last quadrilateral here inside of this circle. And then let's talk about the arcs. So our claim is that angle A plus angle C equals 180 degrees. So you should all write that out in your notebook. But now let's talk about the arc that angle A describes. Angle A equals which arc? Arc BCD over 2 is the same as angle A. Does everyone see why that is? Angle A equals arc BCD. And angle C equals arc BAD over 2. Maybe now you're starting to see what we're talking about. And our last step is quite easy. Another way of writing 180 degrees would be 360 over 2. And now we can simplify even more. 360 over 2 equals BAD plus BCD over 2. And we know that BAD plus BCD plus BCD is 360. And that's a proof. The key clever thing that any good geometer must have done to demonstrate this proof definitively would be to have the core insight that another way of writing 180 degrees is 360 over 2, and to notice that BAD and BCD also total 360 degrees. Alright, so moving on. Problem 1220. Read that out loud to yourself and draw the figure. Don't wait for me to explain it. First, draw the figure yourself. This is one of those deeply satisfying problems, the kind of Sudoku problem, in which you are given some information and you are able to totally fill out all of the unknowns from the information that you have been given. Maybe pause the video and give yourself a few seconds to see how much you can do on your own. When I see this problem, the first arc I want to solve for is arc BC. I know that DE is 50 degrees and DQE is 40 degrees. And if you recall, for finding the angle inside a circle of two intersecting secant lines, the formula is x plus y over 2. That is, this angle is the average of these two arcs. Now, if you're good with averages, you can even solve it in your head, because you know a 50 and a blank would average to 40. But I will write out the problem, write out the formula for you and with you, so we can solve it without any shortcuts. Okay, so we will multiply both sides by 2 to get rid of our denominator 2. And we will see 80 equals 50 plus x, therefore x equals 30. Now the next arc that I see easy to discover is arc BAE. But to do that, I need to find the angle at CQD, also known as BQE, since these are the same. I know this is 140 degrees, because the straight line is 180. And I can do the same process that I did here. 140 degrees equals 70 degrees plus BAE over 2. And that gives me 280 degrees equals 70 minus arc BAE plus arc BAE. And so now I find that 210 is arc BAE. So this whole bit is 210. But I still haven't found the smaller arc, this minor arc AE, which I believe is my ultimate destination. Our next step is to find CPD, which we can do because we have the two necessary arcs in order to do it. Now, if you recall with those two necessary arcs, what we do with them is we take the major arc and subtract it from the minor arc, and divide by 2. 70 minus 30 over 2. And since we already know that this is an angle bisector, we know that this equals 20. And now we have what we need to find BA. Because we already have arc DE, we can find BA. Because we already have arc DE and angle BPA, we can find arc BA. So we know that 20 degrees equals the major arc DE minus the minor arc BA. And I here just use major and minor to mean bigger and smaller. And I get negative 10 equals negative BA, and I'll multiply both sides by negative 1 to make them positive. So BA equals 10 degrees. And now I have everything I need to find AE, the last segment. Of course, this whole thing has to equal 200, but I also know that arc BAE equals 210, and it is made up of arc BA and AE, so I could subtract BA from arc BAE to find arc AE. And this gives us AE equals what? Equals 10. Next, we work on problem 12.21. Let's read that out loud. 3 congruent circles with radius 1 are drawn inside equilateral triangle ABC, such that each circle is tangent to the other two and two sides of the triangle at the same time. Find the length of triangle ABC. So you see it depicted visually. 3 circles perfectly set within one equilateral triangle. And we know that the radius of each one is 1. What is the side of this triangle ABC? So let's start with just writing the things that we definitely know. Do we know any sides? Sure. We know that from the center is 1. We don't know the sides of anything to do with the triangle though. Do we know any angles? I mean, we know that from this tangent to this tangent is 90, maybe? I'm not sure that we can prove that at this point. But what about the angles of this triangle? What are they equal to? All equilateral triangles, their angles equal 60 degrees. So let's just draw a path from this vertex to the midpoint of my circle. And I will draw another one from the tangent line, the tangent point, to the radius. Okay, see if you can solve the length of the light blue line. What do you get for angle DC? What do you get for angle CDO? Of course, that's 90 degrees. And we know that these two lines are equal, CD and let's call it CE. And so we have an angle bisector. What types of little triangle do we have here? How many degrees is DCO? It has to be 30, 1/2 of 60. That makes DOC 60. Ah, 30, 60, 90 triangle, you say. So what is this hypotenuse line from C to O? That's going to be 2. But our question, remember, is we're trying to find this line here, this baseline on our triangle. So what is C to E? It's 1 times the square root of 3, also known as square root of 3 for short. And now we really have everything we need to get the rest of the length of this triangle. Well, you work it out on your own a bit. I'm just going to draw the same figure on this other side. What's the distance from O to P? That's right, it has to be 2. And then for this segment is also square root of 3. And so we have a side. 2 square roots of 3 plus 2. Alright, just 2 problems to go and we're done for today. 12.22. I think this one is the weirdest of the problems we're doing today. I don't think it's the hardest, but I do think it's the weirdest. Part of it is because this diagram is not at all to scale. If you look at this line segment that's meant to be 31, it's basically the same as the line segment that's meant to be 7. So that's confusing. Nonetheless, this problem is totally solvable. We know that line xy is tangent to both the circle O and the circle P. OP equals 40 units, and the radii of circles O and P are 31 and 7 respectively. Find xy. From P to Y, what's the length? It is 7. Good. Now let's do something interesting here. Let's connect this and that, and let's make a line that's parallel to xy, but is always 7 away from it. With that done, you should have everything you need to solve the length of xy. What is length xo? And what is length ax that I have drawn here? So you should also know, maybe one last thing you're missing is labeling all of your right angles. This is a right angle. 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 I'm not saying that YPO is a right angle. It is not. But PAO is a right angle. And you need to get Pythagorean in your life here. So in our diagram, AP equals XY. And we can find AP using the Pythagorean theorem. It's OP squared minus AO squared. And we know what AO squared is because we know that AO is 31 minus 7. $24? Yes, 24. $40 squared minus 24 equals AP squared. Okay, so finish solving out that problem and then take a look at it again. Make sure you understand the steps I took and try to generate for yourself that core spark that says, aha, I need to make a rectangle. I need to make a line parallel to XY. So our last problem 12.23. Median AM of triangle ABC has length 8. Given that BC equals 16 and AB equals 9, find the area of triangle ABC. So first thing I do is I draw a triangle ABC and I labeled my lengths. AM equals 8. And I know that AM is a median. Maybe you don't remember what a median is. But if you remember, the median of a triangle is the line segment that goes from a vertex to the opposite midpoint. So A goes from the vertex to the opposite midpoint. And since we know that AM is 8, and that the midpoint of BC divides BC into two line segments of 8, then as my diagram shows, AM equals BM equals MC. And now we just need to solve for the area of ABC, which of course is AB times AC over 2. But to find AC, my Pythagorean pals, we're going to have to use the Pythagorean theorem. And I'll let you work that out the rest of the way on your own, and then answer the question. And that concludes it for today. Thank you very much for joining us. I hope you're enjoying the way we're doing geometry right now. If you are, please leave a comment. If you aren't, please send me a private message and tell me what we can do to make things better for you. Thank you. Take care. I look forward to seeing you all next time. Arrivederci. Or as they say in Greek, ta leme.